This is the last topic from your chapter 3, and this topic is about meter bridge. So what is this meter bridge? Meter bridge is the simplest applications of a Wheatstone bridge. I hope you still remember about the Wheatstone bridge, especially about the balance condition, that is the product of the resistances in the opposite arm are equal. Now, what is the principle of this meter bridge? The principle of this meter bridge is that under balance condition, the product of the resistances in the opposite arms are equal, which means P into S is equals to Q into R, like in Wheatstone bridge. Now, before we discuss in detail on the applications of this meter bridge to find the unknown resistance, so let me explain to you about the construction of this meter bridge. So in this meter bridge, this is a wire AB, and the length of this wire AB, it is actually 1 meter. So because the length of this wire is 1 meter, so that is why this bridge, it is also sometimes known as meter bridge. Okay. Now, the two ends of the bridge, that is point A and point B, they are connected to a cell of EMF E and a key K. And similarly here, we have in the bridge, right, we have two caps. One is this cap, left cap, and the other is right cap. So in this left gap, what we fix is, we fix a known resistance, that is a resistant box. And on the right gap, we fix an unknown resistance, that is X. Now, you shall see this point, right? When you do the practicals, right, you will learn this properly. This point D, now it is connected to the jockey J through a galvanometer G. Okay. Now, how to get this PS is equals to QR? Okay. Here we will select some resistance from the resistant box R. Let's say the resistance that I'm taking out from this resistant box, let's say it is capital R. So after selecting this resistance from the resistant box, then I will slide the jockey along the wire till the galvanometer give zero deflection. Alright. So when the galvanometer gives zero deflection, what will happen in this case? So look here. Suppose this galvanometer, it is at this point where it touched the wire and the galvanometer gives zero deflection. Suppose this length AG here, let's say it is L. So the remaining length JB, it will be 100 centimeter minus L. Okay, in terms of centimeter, we take 100 minus L. Okay, alright. Also, here, I will imagine that this part of the wire AJ, let's say it is having a resistance P. What is the resistance along this wire AJ? P. And the part of this wire JB, let's say it has a resistance Q. So, because the galvanometer here, it gives zero deflection, it means that this bridge is a balanced Wheatstone bridge. This bridge is a balanced Wheatstone bridge. Alright, which means, right, I can say that the product of the resistances in the opposite arms are equal. Okay, that is R into Q is equals to P into S. Okay, like this. P into S, R into Q. So what is your unknown resistance here? S. So S is actually R upon Q times P. Okay, alright, so this is your equation number 1. So by knowing the resistance R, knowing the resistance Q, and knowing the resistance P, then you can find out the unknown resistance S using this equation 1. Okay, or in other words, if you want to find this unknown resistance S in terms of the length of the wire, then I will say like this. Because we know that the potential, right? If you remember from the theory of, from the principle of potentiometer, it says that the potential drop across the length of the wire is directly proportional to the length of the wire. Now instead of this potential drop, I will write IR, which is the from Ohm's law. Current into resistance is directly proportional to L. Or because I is constant, so if we take it that side, it just becomes like a constant only. So this constant mean it's nothing. I will write R is directly proportional to L, which means the resistance is directly proportional to the length of the wire. So if this resistance is directly proportional to the length of the wire, it means here that this P is directly proportional to which length? This resistance is directly proportional to the length L. This resistance Q, it is directly proportional to which length? 100 minus L. Okay, so putting these two values here, I can say, right, that this S is equals to R, because R now, it is a known resistance. Okay, so this is R times Q. Your Q is 100 minus L, and your P is L. So this L, as I told you, it can't be read from the scale which is fitted on the wooden board parallel to this wire. So once knowing L and R, then this unknown resistance S can be easily determined using this equation number 2. Okay, so this is how we find out the unknown resistance using a meter bridge. And please remember that this meter bridge here, it works under the principle of a balance conditions of a Wheatstone bridge. So this is about the meter bridge.